So naming acids, much like many, many other compounds, and by the way, if you haven't picked up, I'm not a big fan of the way they name things in chemistry because there's different rules for everything, and I would never have set up that way, but I'm not in charge. First of all, how can you identify that something is an acid? At least this year, with one exception, acids are written with an H hydrogen first. Unless, and Courtney, like I've always told you, everything that I'm teaching you is wrong, so here's the exception to the rule that I just gave you. Unless it contains a, what element is that? So you can write the word carbon, or you can put a capital C. In which case, sometimes the hydrogen is written at the end. And already they've confused me. Why? Because I'm not in charge. Such as chaku, which is how I pronounce it. Chaku is in the kitchen you call it vinegar. Does anybody have their pink formula sheet? Chaku is, on the back page next to the polyatomic ions, I did put some of the common acids in the top right corner, right? Except, does it say chaku on your formula sheet, or does it have the H in the front on your... So already we have the H in the front on the formula sheet. So on the formula sheet, the H ends up being there. On the provincial, I think they write it as chaku. And this already drives me crazy, because why aren't they consistent? You know why, Tyra? Because I'm not in charge. I can't change that. It's CH3COOH, which is actually, what's the fancy name for that acid? I called it vinegar, but what's it called on your formula sheet? Acetate? Spell it for me. A-C-T. Acidic acid. And don't get it confused, Rylan, with the polyatomic ion acetate, which is totally different, although it contains C's and H's and O's. Okay? So on your periodic table, if you didn't bother looking, in the top right, I listed, how many acids did I give you there?
4.
The 4 most common ones. This year, aside from chaku, vinegar, acetic acid, you won't see any other acids beginning with a C, with the H on the end. So I wrote, not often seen apart from this. Except, of course, on your periodic table where vinegar is written as, what's it written on the periodic table? H, what does it say? Read it to me, Kyle.
HCH3COO.
Can you see, Allison? It's the same thing, except they put the, this looks like achu or something like that, sneezing, but it's the same chemical formula. Why do they do, I don't know. Yep. Do you have a pen? Oh, Band-Aid? Give me a second here. So, already we have stupid exceptions to the rule that I gave, but basically, you can recognize in this unit, it's probably an acid if it starts with hydrogen, aside from the chaku one that I just gave you. Many compounds, such as HCl, which is called hydrochloric acid, take on acid properties only when mixed with water. For this reason, acids are often written, when you write their chemical formula, Jasmine, as being dissolved in water, which is a little AQ for aqueous. So HCl dissolved in water is written as HCl aqueous. Dissolved in, what's H2O? You can write water or you can write H2O to make a solution. So, the rule then is this, Andrea. Acids are written with hydrogen first, unless it contains a carbon, in which case the hydrogen is often written last. Apparently, I cut and pasted this thing twice because I felt it was worth repeating. So again, our example is CH3COOH, which I always pronounce chaku, even though that's not really how it's pronounced. It's vinegar. And here is the naming procedure. It's going to get confusing. Don't freak out because you're going to have a little reference sheet. If the name would be hydrogen blank-ide, for example, HCl would be hydrogen chloride. When you dissolve it in water, when it's aqueous, it becomes hydroblankic acid. So hydrogen chloride becomes what? Hydrochloric acid. HF, aqueous. How can I tell this is an acid? What's the first chemical? And what can you tell me about what it's been dissolved in? Water. Okay? Then this, at least, and again, there's exceptions, Allison, everything I'm teaching you is wrong, but for Science 10 right now, that'll tell you guaranteed it's an acid.
Plus it says acid.
Pardon me?
Plus it says acid.
HF, that says acid right there?
No, it says hydrochloric acid.
Oh, the previous one. Yeah, but if I give you this, how would you know it's an acid? Starts with an H, aqueous. So normally I would say hydrogen fluoride. Is it UO? Did I spell it right? I think I did. What does it become, Taylor? Hydrofluoric acid. This is a particularly nasty acid. Fluoride eats away at glass. It's one of the only, I think it's the only element that eats glass. So hydrofluoric acid can't be stored in glass jars. It has to be stored in a special chemical. It's a plastic polymer resin bottle thingy. So all the glass jars that we all have for all our test tubes, everything, hydrofluoric acid doesn't work in them. I might even have a little video about that later. Yep.
Do you have hydrochloric acid here?
You know what? I'd have to check in the chemical storage room. I doubt it. Now, so you ready? Ide becomes ick. Ide, ick. If the name would be hydrogen something 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 8, it also changes to ick. Now, how could it end in 8? It would have to be one of those polyatomic ones on the back page of the pink sheet, where you had carbonate, and where you had sulfate, and where you had chlorate, and where you had, so how can it end in 8 from the back sheet? Hydrogen carbonate, which is H2CO3, if it's in an aqueous solution, does it start with hydrogen? It's probably an acid. That becomes what is CO3 from the back of the pink sheet? You might want your pink sheet out now, I guess. What is CO3? So this becomes, oh, sorry, no hydro. I apologize. I didn't write hydro in front of here. It just becomes carbonic acid, not hydrocarbonic acid, carbonic acid. 8 becomes ick, but no hydro. We're going to summarize all this in a second. What about H3PO4 aqueous? Does it start with an H, with a hydrogen? Check. Is it dissolved in water? Is it aqueous? Check. Probably an acid. So normally you would call this, if it wasn't dissolved in water, hydrogen, what's PO4? Phosphate? It becomes not hydro, it becomes phosphoric acid. Okay. If the name would be hydrogen blank 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 ite, which are the ites on the back of your periodic table? There's a sulfite, there's a chlorite, I think there's a phosphite. Is there a carbonite? Can't remember. That changes to blank blank us, O-U-S. So hydrogen sulfite becomes, does it start with a hydrogen? Check. Is it dissolved in water? Check. It's an ite. It's going to become sulfurous acid. Not sulfuric acid, which is something different. Sulfuric acid would be a hydrogen and a sulfur. HClO2 aqueous. Is that an acid? How do I know? Two ways. Starts with hydrogen, dissolved in water. I would call, what is ClO2? Chlorite. So it would be hydrogen chlorite if it wasn't dissolved in water. That's going to become chlorous acid. To me, Joseph, this is horribly inconsistent and confusing. By the way, part of the reason the chemistry names are so wonky is they evolved over 300 years of the alchemists that were trying to turn lead into gold and really didn't understand chemistry, but they were giving things names. And then slowly, as we understood more, the naming conventions, Lydia, have stuck around. So we're stuck with it. Summary then. I wrote, do I have it here? Yep. Ide becomes hydroic acid. 8 becomes just blank blank ic acid, no hydro. Ite becomes blank us acid. Ugh. So, ugh. With your pink sheet out, let's see if we can get the chemical formula. Yep. Ide and 8 become ic, one with a hydro, one without. Ite becomes us. What's the chemical formula for each of the following acids? Okay, so now you're going to want your pink periodic table. We're going to have to use the crisscross rule, and we're going to try and come up with the formula. So, sulfuric acid, what does it end in? Ic. So now I would say, if it ends in ic, what did it come from? Let's see. It could have been 8. It could have been ide. Do they have a hydro in front of the word sulfuric? Then it must have been from an 8. This must have been hydrogen sulfate, H2SO4. Holy smokes. Whew. Perchloric acid. Say what? Okay. What does it end in? Ic. Is there a hydro in front of it? So this must have been perchlorate. So I have hydrogen, which is a plus. What's perchlorate? Please tell me that's a polyatomic ion on my pink sheet. It is? What's its formula, Matt? Can you read it to me? Ci or Cl? I think it's a lowercase l, right? Because if it was an I, it'd be uppercase and it'd have the little wings on the I, right? So ClO3, and what's its ion charge? ClO3, what's the charge in the top? O4, sorry. Negative? When I crisscross, how many hydrogens and how many perchlorites will I need? 1 and 1? So the formula is going to be HClO4, and then I'll put in brackets aqueous, AQ. Phosphorus acid, I think it's supposed to be phosphorus acid, and I think I was typing too fast. Anyways, OUS tells us it used to be ITE, so it's going to be hydrogen phosphite. No, I guess it would be phosphorus, because phosphite doesn't have an OR in it. So you ready? Nitrous acid, it ends in OUS. That tells us it's hydrogen and nitrite. So hydrogen, I know the formula for. It is H and it's a plus. What's nitrite? I know I don't know what it is. NO2, and it's got a negative. So when I crisscross, I guess the actual formula is going to be H1, which I'm not going to bother writing. NO2, 1, which I'm not going to bother writing. That there is, and then put it in water. AQ. That's nitrous acid. Hydrochloric acid. Okay. The hydro and the ic tells us hydrogen chloride, HCl. So hydrobromic acid, I would say, okay, has a hydrogen, has a bromine. I know the charge on hydrogen is H. Bromine, what's the charge on bromine? Negative. Oh, these are nice. They crisscross quite nicely. So the formula would be HBr aqueous. I have reading check, page 227. Answer them below. We're going to do that in a second. I have a worksheet for you to practice this, but I want to give you some good news. Here is the good news. However, every few years, this is one multiple choice question on the provincial. I've covered it, Jasmine. I'll put it in your notes. I'm going to give you a worksheet to practice this. I'm not going to throw this on a quiz. I'm not going to throw this on a test because it's such an obscure thing and it only pops up every so often. It is in the grade 10 learning outcomes. I'm not going to waste a bunch of time flogging this because you can get lost in this for 3 days trying to figure out the naming. Okay? In fact, let's see, how much more do I have to cover here? Production of ions. Before I turn you loose on the reading check here, let's get to naming bases. Oh, you know what? Actually, here's what I want you to write. Up here where it says reading check, you can cross that out, but here's what you can write. You need to know the acids on the pink sheet. You need to, Courtney, recognize those four. Those are the ones that'll show up. In other words, if you see HCl and you don't clue in that's an acid, you're in for a long day. What are the four that are on the sheet? There's the chaku, the vinegar, the acetic acid, hydrochloric acid, right? What are the other two that are on there? Sulfuric acid, which is sulfuric, is it HSO4 or is it H2SO4? Sorry, didn't crisscross right. And what's the fourth one? Nitric acid, okay? So, key idea, how do you recognize it's an acid? What does an acid start with? H. Why? And H is also, when it's an ion, like a proton. It's a +1. What would a base contain? A base would have to contain a -1 charge somewhere because acids and bases are opposites. So if you turn the page to naming bases, here we go. This one is much more consistent, at least in grade 10. How can you recognize a base? You can recognize a base because it's written with an OH at the end. It ends in O. Is that a base? Oh! Whatever stupid way you want to come up with to remember that. Alex, question? Or quick like a bunny. Okay. How do I recognize an acid? Starts with an H. How do I recognize the base? Ends in an OH. At least there's kind of some symmetry there, starting with, ending with. Okay. Naming, oh, thank goodness, is the same as before. Nothing has changed. OH has a name. As a polyatomic ion on your periodic table, what is OH called? So NaOH is going to be sodium hydroxide. KOH would be potassium hydroxide. Calcium hydroxide would be, calcium is +2. CaOH in brackets 2, but calcium hydroxide. Highly reactive bases, ones that would burn your skin, are called caustic. What are some caustic bases? Tyra, you have the yellow sheet in front of you. Look at the pH scale. Head off to the right. What's the one on the very far right on the pH scale? What's caustic? What do you have to wear gloves if you're using? Oven cleaner. Okay. What's the one just to the left of it? So even bleach, if it pours on your hand, what does it do? No, well, what does it do to clothing? It really rips out colors, right? So I wrote down here, see text page 227 for a chart of common bases. I'll just show you the chart so you can see some of them. Let me pause the video here. I may or may not assign the reading check. I'll come back to that in a second, but let's turn the page and kind of finish this off. So what happens? How do acids and bases fight each other, neutralize each other? Julia, you gonna make it? You sure? I don't know. Hang on here. So, acids and bases are chemical opposites. Are chemical opposites. What does that mean? Well, it means that acids have lots of H+ of protons to get rid of. And those protons want electrons, which is why acids can rip electrons from your skin and burn. Bases have lots of OH negatives, hydroxide ions, which want a proton. They're negatively charged. Now here's the nice thing. If you mix an acid, Alex, and a base together, well, what would you get if you add H plus O plus H? When you mix acids and bases, it turns out, Allison, one of the products is water. Kind of nice. What that means, a solution can't have high amounts of both. If you mix an acid and a base, here's the fancy word that you want to know, neutralize each other. Those extra H's, Tyra, and those extra OH negatives join together and water. Oh, and what's the pH of water? 7, neutral. That's why, because they neutralize each other. In fact, as a picture, right here in the middle, this would be a neutralization. What you're saying when you have a neutral solution, Joseph, you're not saying there's no H pluses and there's no OH negatives. What you're saying is you've got an equal mix of both, and they're going to just neutralize each other. As you get more acid, you're not saying that there's no OH negatives. What you're saying is you've got extra H pluses. That's an acid. When you become more alkaline, fancy word for basic, you're not saying you don't have any H pluses. You're saying you've got more OH negatives. It's alkaline. It's basic. So, in fact, when H plus ions and OH negative ions combine, they form water. So really, pH is actually a measure of the H plus ions, how many those are. That's why it's called the power of hydrogen. So a solution of pH 1 has more H plus ions, has more hydrogen ions than a solution of pH 2. And a solution of pH 2 has more hydrogen ions than a solution of pH 3. A solution of pH 9, which is on the right side of water, which is more basic, has very, very few H plus ions, but lots of OH negative ions kicking around. Solution of pH 10 is even more OH negative ions. Little nerd note here. So the concentration of H plus of hydrogen ions is the number of H plus in a defined, I didn't leave much room here, volume. So when they talk about the concentration of ions, they're not saying how many there are, they're saying how tightly packed together they are. Highly concentrated means, oh, you've got a lot of ions in every milliliter. Because I could have a bunch of ions, but if the container was the size of this room, it's not very concentrated. I could have a few ions, but if the container was the size of a thimble, it could be very concentrated. Is that okay? Nearly done. I got a cool video to show you. I only found out on the weekend, so. Oh, a solution is a liquid with something dissolved in it. I wrote here, see the chart on page 229 for a great summary of the properties of acids and bases. Okay. Let me show you the chart on page 229. So for now, I think, I'm not going to cross this out, but I think that can be part of when you're reviewing for the test later. This would be a good kind of a summary of this whole section. Your homework for today for next class, first of all, get the pH color sheet done, and then you can do the names of acids. Remember, I'm not going to ask you any of this on your test. I will not. But it might show up on the provincial. It shows up every few years as one question, and okay. Answers are attached to the back of this, and then there's this larger acids versus bases sheet. I think you can get that done in class actually, you know, you can get all this done in class pretty easily. This is really not that long. I'm going to change my mind. Sorry, Taylor. I'm going to change my mind and say, you know what? You can also get these questions on a separate piece of paper done. You got 25 minutes. Oh my. Okay. You got the remainder of class.